hole in my heart, for not being able to check the word while you're here. You should try catching.
That's what I'm doing now. It's with the catching area.
Yeah. I did everything, all the trash up front except for the side. Find the set constant, and then just line it together.
So, essentially, I'm doing it differently which always is a problem here because when I search up, I'm like, oh, even gave me this.
All right, everybody, welcome to class. So today we will talk about exceptions, and we'll also cover wrapper classes briefly. And so one thing I wanted to point out is that on Friday, I'm not going to be here, and so our class period, our lecture class period, is going to be led by Assad, who is a TA for 2 of the sections. So he might be your TA, he might not be your TA, but he is a graduate student here, very knowledgeable. And so he will be here for just an open Q&A, sort of problem-solving session. This will be after you do Lab 4, which, like I said, is going to be the starter code for your Project 2. So if you are having any problems with Lab 4, you'll already have turned it in, but you'll kind of be in a good place to start Project 2 after that, so it could be a good time for that. We also have the quiz coming up next week, and so if there's anything that we've gone over in class and you're just like, I don't understand that, can we just go through a problem about that or go over that topic again? This will be an opportunity for you to have just an open Q&A session on Friday. So today, and also I may have Assad go over Project 2. If we have time today, I'll get to it, but probably I'll have him talk about Project 2. I'll just intro that for you. So today, quickly at the start, I want to talk about wrapper classes. So these actually are way earlier in our book, 1.3, that's like page 12 or something. But basically in Java, if you remember, we have our primitive data types, so things like ints, Boolean, etc. And then we also have our reference data types, our objects. And there are just a lot of times where we need an object to work with Java. So for example, I think after the quiz, we'll talk about array lists, which are kind of a nicer implementation of an array. And if we want to work with integers, we can't put ints in an array list, for example. We need to put objects into array lists. And so to deal with this, Java has something called wrapper classes for the primitive types. And our book is actually already kind of outdated on how these are used. So rather than point you to the book, I am linking you to a quick tutorial. So if you need an extra reference in addition to this class, you can follow that link. So we'll just go right into this and see a demo. And so I'm going to make a class inside of my day 12 package, and I'm going to call this wrapper demo. And I'm just going to make this big for us. And okay. And so I'm just going to make a main method here. Because the whole point is just to play around with these wrapper classes. So, all right, so let's just work with integers. So we can all remember, if I want to declare a variable called a, that's an int, and store the value 8 in it. That's how I would do that. But if I want to work with integers as objects, my wrapper class, very cleverly named, is just integer. So if I want to declare another variable b of type integer, so the old way that you might do this, and I'm just pointing this out because you might see it, and also because Eclipse has a nice way of telling me that this is the old way and I shouldn't do this anymore. The old way of declaring or initializing an integer type was to use the constructor that looks like our constructors for all of our objects, right? When we make like a string, we use new, or no, rather, when we make something like our calculator or a scanner that we've seen, we use the new keyword, and then we use the constructor. And so you used to do that for these wrapper classes as well, but Eclipse is like, hey, that's not how you do it anymore, so this would be wrong. Instead, if I want to make an integer, I do something much nicer, and I can just say my integer b is just, say, 12, if I want it to be 12. And now b has the type integer, the wrapper class, instead of the type int. And so these wrapper classes are very easy to work with. Again, we can see that Java's giving us the behavior of creating this integer just by putting in 12. It also has what we call automatic boxing, and unboxing. So, for example, if I want to make an int c, and I want this to hold, so b is a reference data type, right? It's actually holding a memory address pointing to the object of type integer that has the value 12, like we could access that value. But now c is going to be a primitive data type. It actually should hold the value 12. And Java can interpret this for me. And we call this automatic unboxing. Sort of like the integer, the variable b is an object, and Java is automatically getting the value that's held inside that object. Similarly, if I do something like, so b is of type integer, not int, and I just say something like 3b should be assigned to the value of 3 times a, so b should be integer type. And here, so we would call this automatic boxing because a was an int with value 8. And so when we multiply 3 times 8, well, that's just 21. But because b is of the integer type, this value is put into an integer object. Call that automatic boxing. So you can work with these integer types basically how you would with ints, but they come with some nice property or some nice things which are, just for our purposes, some methods that we can use. So let's take a look at that. So you may have noticed that sometimes when we're working with objects like strings, casting doesn't work how we want it to. So suppose I have the string x, and it's a string, but it's the string minus 12. And a natural thing that I might want to do with x is turn it into an int, right? But if I try to do something like int y is, if you remember the syntax for like when we were casting doubles to ints and etc., we had the syntax where we put the type that we want to cast to in parentheses, and then the variable or the value that we want to cast after it. So I want, it would be understandable for me to want something like this to work, because we know the syntax, it's really clear, it's easy, but it doesn't work for objects. I can't cast, oh, this isn't what I want. Still doesn't work though. I want y to be the int minus 12, but I can't just use this syntax. And so this is just not going to work. I mean, if I try to run this, it's like, hey, you got an error. Can't cast from string to int. But with my wrapper classes, I have some useful methods. So let me comment this out so that we can actually run our program. Instead, I can use the static method parseInt, and parseInt takes a string, for example, x. I guess Eclipse is correctly guessing that I want to pass x in. And so now the int y is holding minus 12, and we can double check that by running it, and indeed it is. And so if I want to be moving from strings to ints, or the same syntax is going to work for other wrapper classes. For example, if we wanted, like, I can't even remember, is Boolean? Okay, yeah. If we wanted, we'll just put this down here. Boolean flag is boolean.parse boolean, and again I could parse a string like true, and so that same syntax works for all my primitive types. Okay, are there any questions so far? Great. Okay, so we had a string and we were able to get an integer out of it. Now, the other way we might want to go is we have an integer and we want to get a string out of it. And you may have also noticed that we can't cast that way. So let's say I have a string w. Oh, let's say I have an int z, and it's some number, -6. And again, I want the string version of that, right? Just like I want -6 as a string. And I'm going to call that w. And again, I can't just cast it how I would want to do it. Like, I want this to work, but it's not going to work. And so instead, I can use, again, the wrapper class, and I can say string w is instead, if z was already an integer, the method we want to use is toString. So I want to do something like z.toString, right? But also this doesn't work. So does anybody have any ideas about how I can use my wrapper class so that I can kind of massage this code into something that's going to actually get me my string back? Or just kind of general ideas about what I want to do. Yeah?
So like integer.parseInt, am I correct in assuming that's like a static method?
So yeah, that's a static method.
And so in the case of wanting to convert z to a string, we probably want something with like within string that has a static method.
Yeah, that's a really good idea. So, and maybe that would actually work. So going along with this sort of idea that we had here, if I could do something like, string.parse parseInt or something like that, then that would work. And yeah, you're right. If we were wanting to go from a string to something else, then that would be what we want to do. But instead, I'm trying to get at the idea of if z was an integer, like if z was this integer class or an integer object. Integer objects have, so I can give an example here. Y, let's say, so y is, oh no, y is an int. We have one up here. So b is an integer. And because b is this object integer, it has a bunch of methods that can be useful to us. So for example, b has the method toString. And so if I wanted this integer 12 as a string, I'll save this string example is b.toString. And so now what's actually stored in an example is the string 12. Does that make sense? Okay, so now that we know that if we have an integer object, we can call toString on it. Down here, we don't have it. Z is not an integer object. But we can convert it to an integer object. And I haven't told you the method, the static method to do that, but it is integer dot value of, and here, I guess it knows what I want to do. I can create an integer object from an int by calling value of on an int, for example, 6 minus 6 here. And then I can chain together these methods. I can call toString on the result of this. So then I'm calling toString on an integer object that has the value minus 6. And so then W would finally be string W has value minus 6. And so these are just some examples of how we can use these wrapper classes, sort of where we want to hope to cast between types. Yeah.
So how do you, or why is value of static? I know it's italicized.
Yeah. Do you have any ideas? Well, so anyone else have any ideas? Yeah.
Specific to the class rather than instance.
Yeah, so that is the definition of what it means to be static. And I think this one we can think through because, well, I don't have, like, I'm creating an integer object. I'm kind of creating an integer object out of nothing, right? If it was a concrete method, or not a concrete, like a non-static method, then that's something that I call on an instance. So I would need an instance. I would have to do like b.value of, right? So b is an instance of integer. If I call b, it doesn't really make sense to say b.value of and get back an int, an integer object. It's like I'm creating this new one in a way. Yeah. Yeah.
So instead of writing what you wrote on line 28, could we have just said like z is now assigned to the capital I integer of z, and then say z.toString?
We could do something. I mean, yeah, like something like integer z is minus 6. Like if we had done this from the beginning, maybe this does actually work. Yeah. So if we had just done this integer z, and then now we could do z.toString.
So you were just making a nice one line thing to make it an integer.
Yeah. Yeah.
So
yeah, let's see. String dot value of, and then z. That's a good idea. Oops. Yeah, I mean, I think that looks like it's going to work out for us. W. So. Yeah, thank you. Yeah. Yeah, good idea. So W is a string. It's just, I mean, yeah. And I guess this will also work if we do this, either way. Value of can take in our primitive int or our object integer. All right. Okay, so this is, you'll see these wrappers, and now you know, if you see this capitalized integer, like full word integer, now you know we call this a wrapper class, and it's nice because we have these methods instead of just this primitive value. And these work for all of our primitive types. Okay. So another thing that you will certainly run into, and you've probably already run into, oh, I thought that was a hand, but it's a water bottle. You'll certainly run into are exceptions. So exceptions are these unexpected events that occur during the execution of a program. They're exceptional things. If you want something to understand why is it called an exception? And just sort of in the programming way of speaking about programming, we say that an exception is thrown by your code, and then potentially our exception can also be caught. And so the general syntax for this, since this is probably pretty small, let's just go over to a new Eclipse file, a new Java file, and this is going to be called exception demo. And I'm just probably going to put this in a comment. So this is our general, going to be our general syntax for exceptions, but let's work our way up to this. So suppose I have a program, super simple program. I'm going to have, just put this in here. And our super simple program wants to get input from the user and convert it to an integer. So we want to store an integer from the user. And so we know about scanner. To start off, let's just use scanner. And I'm going to let Eclipse import it for me. New scanner system.in is my syntax for making a scanner. And it's going to be like, hey, you don't have scanner. I'm going to say, great, add it for me. And now I have it. Okay, and now I'm just going to prompt the user. I'm going to say, hey, enter an integer. And then I'm going to store that integer as the next, whatever comes next from my, oh, yes, that is correct. Okay, I'm going to store whatever the user enters as a string, and we can use, ooh, no, okay. I'm going to call this string from user, and then I'm going to say my int n. I can use my integer wrapper class. Can anyone tell me how I can create this n? So we parse this. What next gives us back a string. we saved it as a string, and now assuming they gave us something that can be read as an int, can anyone tell me, remember back from our wrapper demo, how I can use the integer wrapper to actually get an int, convert this to an int? What was that? I saw a hand. Yeah. Yeah. Yeah, I can use the parse int method, and totally reasonable if you didn't remember that. But so now I'm passing this string from the user into my parse int method, and this returns me an integer. But let's ask ourselves, what could go wrong? Any ideas about things that could go wrong in this program?
You have non-integer entry.
Yeah, they could do something that's not an integer. Like, for example, let's just run this, and being a really great user, I'm like, oh, enter an integer, 12. Love that integer. So I type 12, and our program, like, maybe it doesn't need to handle this super nicely. It doesn't need to actually read the string 12 as, you know, the integer 12. But it should at least handle this gracefully, right? And so reading what's coming out here, we see what's happened. There was an exception. And what kind of exception? A number format exception. And so coming down to our try-catch syntax here, the way that we can handle this is, let's first wrap this in a try statement. And I'm going to indent this because that's how it's usually done. And then, so as soon as this, by putting these statements into my try statement here, as soon as an exception is encountered, I will just jump straight into however many catch statements I have in order. And so I need to put the type of exception that I want to catch. So this is a number format exception that I want to catch. I'm just going to copy that and paste it in here. And then, so the standard is to save this, use the variable name e for exception. So can anyone tell me, like, when I'm saying number format exception, what is, and then e, can anyone tell me, like, what are those two words? Yeah.
So if it defines an exception that's number format exception, it will assign that to the variable e, so you can continue to reference it to see.
Yeah. So I have a way to hold on to this exception, and I'm saying that it's of type number format exception. So, you know, just like everywhere in Java, we always have to specify a type. So just so this isn't mysterious, you know, this is the data type, and then this is the name for the variable. And what should we do if we do encounter one of these? Well, one thing we could do is just print, hey, you know, invalid integer argument. And maybe in this case, you know, we could do something like have a while loop that is just going to let them keep trying, but maybe we want to just assign it to some default value. So I'm going to do that, assigning default. And so I'm going to say my n should be, let's just make an overall class constant here that's going to be called default, which I can declare up here. I'm going to call it public, or I'm going to make it public. And so here I'm saying my class has this constant field default, and I can just use it later. I wonder if this is... okay, so can anyone tell me, you might not be able to see it, but can anyone tell me why my n is giving me a problem here?
Is that a typo?
Yeah, okay, so we want it to be the same n, right? But this n is local to this try statement. And so if I want this n to be sort of at a higher level, I am going to declare it outside of the try statement. So I'm going to say int n, and I'm just going to start it with being default. And then now, in my try statement, I assign it to whatever the user gets me. But if I encounter a number format exception, I will catch it. So my program will continue. I'll print this message, and then I'm going to set it to default. And let's just, at the end of our program, let's print out n, just so we have an output here. So now I'm going to try entering 12 again. And instead of having all that red text and having my program just quit, I now have some useful output. I was able to continue. I assigned my value to something that made sense, and we can continue on. Yeah.
So since you said public static final int for default, how come we can change that? Wouldn't that make it a constant?
Yeah, so exactly, but the variable default is the one that's constant, not n. So yeah, exactly what you're saying would be, if I said int final int n, I don't know if I can actually do this in the middle, but maybe I can. This is what would then cause me problems now. So now my n has some red squigglies under it, and I probably won't even be able to run my program. Yeah, it says I can't even compile. This is not even an exception. This is a compilation error, so I don't want to do that. I just want this variable default to be my constant, and then n is just a regular variable. Yeah.
So why do you need final if you're going to override?
Well, we're not changing default,
Oh.
right? This is just kind of like a code readability, code reusability, maintainability thing. Or maybe I come back to my program and I'm like, my default integer is 1. No, the default integer should be 0. That makes way more sense. And then now I don't have to go change a bunch of places.
Okay.
You know, if you're going to be reusing, if something's sort of like a constant for your whole program, then it's better to have it as a constant field. And that's when we use this all caps. And it's also, I think it's blue, and I wonder what happens if it's bold and italics. Probably because it's static and final. I think final maybe is bold, static is italics. So yeah, that's just kind of a style thing that we got going on. Yeah.
So it's really cool to like catch exceptions, but at what point are we supposed to have like defensive programming, and at what point do we use like exception catching?
Yeah, that's a really good question. So, well, do you want to say what you mean by defensive programming?
So like if I'm programming this, I'm thinking, okay, my user might try to like use this, or it might just be dumb. I should make sure that they can't screw it up.
Yeah.
I would say, okay, so if like input.nextInt is true,
Yeah.
then continue. If not, print out a statement and ask for another input.
Yeah. I think. Let's see. I mean, maybe it kind of depends what you like. If I do really need to run this, I do really need to get that integer from them, then maybe I do want this sort of loop where I say enter an integer, and then if they don't enter an integer, I say, you know, for example, you know, 1, 2. And I just go until I get the integer from them. I can also think of maybe I have just a much more complicated system and like something could have gone wrong. It's not even the user, it's just like it works on my computer, but then I'm putting this code out into the wild and the person that's running the software might just have a different configuration. And so I can't just be like, hold on and fix your configuration or something like that. You know, I should exit gracefully and say, no, you need to go fix this and then run it again. Yeah. Yeah.
So I tried to like call the main function again to like recurse it, but I couldn't figure out how to do that because it's like main take a special type of argument. So is there a way to do that? Just
Interesting.
Like calling main again, to have main run from the top again, and after
I don't think so. So yeah, you're saying, I would say that you'd want to, so your idea here is like down here. The idea is if we don't get an integer from them, rerun main. Is that your idea?
Yeah.
So yeah, that's a good idea. I think you might want to just, instead of rerunning main, just make another method that is get user input. So instead of rerun main question mark, how about method get user input instead. So I could do something like define, I have a static method, maybe it's not void, it's int get user input, doesn't need to take anything, and then this is where I put my scanner ask user for input and then return n. So that could be, or maybe I make my scanner, maybe I have to pass my scanner in. But if you did want to go for that sort of approach, then I would say put that in its own method rather than trying to rerun main. Okay, any other questions? Yeah.
What happens if you print the
Yeah, that's a really good question. So let's try it out. And let's print eat. So we want to make this happen. Yeah, so basically E has a nicely defined toString method that's being called. And what that toString method does is it's telling us what kind of exception is it. And then it has this nicely defined behavior where it says for this input string 12. So this actually goes, I think, nicely into the next thing that I wanted to show, which is we can also, so not only we can catch these exceptions that are generated by existing Java code, but we can also throw our own exceptions. So what was the example that I did? Well, so let's say that our program doesn't just want an integer, but it actually wants a positive integer. So I'm going to say enter a positive integer. And so right now, let's say I run this, and I enter -8. And right now, my program's not really running how I want it to because the user is not being told that they're able to just enter a positive integer and everything continues on. So what we can do is if n is negative, throw an illegal argument exception. And so how do we do this? Well, we can say if n is less than 0, we want to, and it's easy, we want to throw, and then a new illegal argument exception, and we can pass in the string that we would like to go along. If we actually print this exception out, we can say what the string that we want to be printed out is. So let's say something like negative input. And so now to add, if we want to catch this, we can add another catch statement, catch an illegal argument exception. Actually, let's not catch it first, and let's see what happens then. So let's run it, and again, I'm gonna enter something negative, and look, we threw our own exception, and it worked. And oh yeah, and you can see that our, the string that we input is what was printed. If I change this a little bit, I would see that changes. So, and I'm gonna do -8 again, and now it's got an exclamation point. So now how do we catch this? We just add another catch statement, legal argument exception, and let's call this E per the standard, and I'm just going to print this as well, and again I'll just set it to default, and let's go ahead and run this. So -1. Oh yeah, and we changed our default to 0, so that's why at the end we printed n. It was 0 because we threw this exception, we caught it, and then we executed the statements that were inside the body of our catch statement. Are there any questions about that? All right, great. So that is throwing and catching exceptions. Let's look back at the page. So we just, this is just that same syntax that we just looked at. So of course, in Java, everything is an object. This is from your book, but just a part of this hierarchy of types that are throwable. Let's see, did any of these? We didn't actually work with any of these, but somewhere in this hierarchy is where the number format exception lives and the illegal argument exception, because obviously these are throwable, so they inherit from throwable. And I guess, I'm not sure if throwable is an interface or a class, but regardless, they have this inheritance hierarchy. So yeah, that's all that I wanted to cover today. One thing, if you want to get some more practice, both with these catching exceptions, and also with the command line arguments that we learned about on Monday, there's an additional exercise here where you can go from what we've done in class. Oh, I might actually have the answer already in the file online, so if you look at that, you might get the answer already. I can't remember, it might be in a comment in there. But figure out how you can actually use this array args, and if they just don't enter anything, catch that exception. Maybe that. Oh yeah. So any ideas about how we would do that? What part of the code we would first have to change in order to get? So right now we're getting our N from scanner. So if we wanted to get it as a command line argument, any thoughts on how we would change? Yeah.
You could do like R brackets and put an index value.
Exactly. So rather than, all this, rather than this from user business, we would want to do something like args at 0. I guess this is what we would do. We would want to use this args array and get that input from the user. So that's how we would start to make that change. But if they don't enter a command line argument, that's when we would need to deal with that exception. So that is where I will leave you today. Come up and ask any questions, and also be ready with your questions on Friday. Good luck with the lab this week, and I will see you on Monday.